Hello, everyone, and welcome to the webinar between Ride AI and McKinsey. We will start the webinar in approximately 2 minutes. I'm James Gross, and locally my time is 8 a.m. right now, so we'll start at 8:02 Pacific time. Okay, it's now 8:02 local time. Again, welcome everyone to the McKinsey and Ride AI webinar. We're very excited to host you today. We have a lot to get through. By way of introduction, again, as I mentioned, I'm James Gross. I'm the founder and CEO of Ride AI. My work is primarily in software and also in mobility. I've had the great pleasure to work with McKinsey in the past as one of the co-founders of Micromobility Industries, where we ran events like Micromobility America and Micromobility Europe. I will say one of the best presentations every year when we had those events was from McKinsey. All the founders, entrepreneurs, venture capitalists always enjoyed their data and how meticulous they were with gathering their data and presenting it back to the industry. So I'm very excited for the first time to do this in more of the autonomous vehicle space and AI space. And so with that, I'd like to pass to the first introduction to our panelists, and that'd be to Kersten Heineke of McKinsey to take over and introduce himself, and then we'll allow the rest of the panelists to introduce themselves as well. Finally, I will take questions during the webinar, and we'll do our best to answer the questions at the end, giving ourselves about 20 minutes. So please start asking as many questions as you like, and we'll hopefully get to them at the end. With that, Kersten, I'll send it over to you.
Thank you so much, James. A great pleasure to be here, and thanks for the fantastic collaboration over the last couple of years. And I'm looking forward to continuing this collaboration over the next couple of years at Ride AI. I'm Kersten. I'm a partner at McKinsey, co-founder and co-leader of the McKinsey Center for Future Mobility, our unit that deals with all things mobility. In the Center for Future Mobility, I'm responsible for autonomous driving, shared mobility, and micromobility, and all of the different connections thereof. Work with companies across the entire ecosystem, both in the traditional industry, automotive, but then also spend a lot of time with tech companies, startups, scale-ups, and work across almost the entire globe on autonomous driving topics. Martin, over to you.
Good morning and good afternoon from my side. Martin Kellner. I'm also with McKinsey & Company, partner in the Munich office. I'm also I'm working with Kersten within the Center for Future Mobility, and within the center, I'm leading our activities we're doing in ADAS and autonomous driving. I work with OEMs, tier one suppliers, tech disruptors, but also investors on this topic, really across all use cases and along the full value chain. And with that, I would hand over to Dave.
Great. Thank you, Martin. I want to thank the hosts for the opportunity to talk today. My name is Dave Tokic, VP of Corporate Development at Torque Robotics. Torque is a AI software company delivering autonomous driving software stacks and support software for the autonomous trucking space. And I've been with Torque about 3 years, heading up Corp Dev. Prior to that, I was with Algalux as part of the exec team where we were building highly robust perception stacks for automotive and AV. And we were acquired into Torque about 3 years ago. And then prior to that, in the semiconductor industry in various executive roles for roughly 20 years. Looking forward to the discussion today, and I'll hand it over to Malte.
Yeah, thank you, Dave. Malte Exeler, Digital Product Strategy at BMW. So happy to be here, happy to discuss what's next for autonomous driving. Myself, I'm working on this topic. I have to calculate back. I guess it's more about than 10 years now, and still excited what the future will have for us in this space, and happy to have your questions later on. So I hand over to Sascha.
Yeah, all greetings from Hamburg. I'm Sascha Meyer. I'm the CEO of Moya GmbH. In my capacity for the Volkswagen Group, I'm in charge for the commercialization of all autonomous mobility offerings. And we launched our ride-pooling service here in Hamburg as a flagship operation back in the days 2018. I joined the company in 2017 as Chief Product Officer and became CEO in 2023. And before that, I've been in management consultancy for quite a few years, helping large and mid-sized companies to find a way to digitalization of, I would say, complex logistical businesses. And so I hand over to Talmi.
Yes, hello. Thank you for hosting me today. My name is Talmi Fridman. I'm leading the strategy team at Mobileye, which is autonomous driving and ADAS full stack provider. I've been with the company for the last almost 6 years. Also coming from a management consulting background, although I hope you don't hold that against me. And just excited to be here and participate in this forum.
Amazing. Thanks, everyone, for joining us here. We wanted to make sure that everybody who participates does not only get to see the McKinsey view, if you will, but also gets to hear from the people that are working on autonomous driving day to day, hands-on, and have the experience of seeing it progress every single day. Now, what we wanted to share with you today is the findings of our biannual expert survey. So it's now the third year that we are doing an expert survey, asking people from the industry how they think autonomous driving is going to be deployed, how it has evolved over the last couple of years, and we are asking always a long list of questions. This year, and like I said, it's the third time we are doing it. We did it previously in 2023 and 2021. We asked 91 participants from across the world. You can see that Europe is a bit overrepresented probably, but we also have participants from other geographies. And we asked people from different parts of the ecosystem. You can see a few of the exemplary logos here, different seniorities. So we are quite happy to see that this is a fairly representative sample of the industry. And what we are playing back now is basically what these experts have shared with us. So this is not the quote unquote McKinsey opinion, but it is what the experts in the industry have told us how they see autonomous driving evolving in the next couple of years. The first page I would like to start with, and the first analysis we did, is the timeline. So we did ask people, when do they think certain use cases are going to come and become live? And basically, what we can see is, and this is a similar pattern to what we saw between the 2021 and the 2023 survey, is that the timelines have shifted. So we can actually see that in the last 2 years since we did the last survey, the timelines have shifted between, in some cases, 1 year, in other cases, 2 years. What we can also see is that the timeline shifts are less so for level 3. They are a bit higher for trucks, and they are highest for L4 for the urban pilot, so for the private application. You can also see that there is a big range of outcomes depending on where the people are based. So basically for the different geographies. And there's a clear pattern that China is definitely leading the pack for most of the technologies. North America is, if you were to take an average here, second. And then Europe and APAC are sort of laggards, if you will. And you can actually also see that the gap between the different years is quite broad and has actually widened further compared to previous surveys. We've asked ourselves, why is that the case, and why is Europe lagging? Why are other geographies a bit more advanced? It's a combination of pace of innovation. It's also a bit the cultural factors when we take a look at the different organizations. Regulatory complexity obviously plays a role. But then last and definitely not least, we also see very different funding levels across the geographies, especially in Europe. And I have to admit that this is a big problem for Europe. We also see the funding being concentrated on fewer players, in the sense that you have lots of players that receive very little funding instead of having a few players that receive a lot of money and then therefore can advance very quickly. There's other topics as well, but I think my goal here would be to get a few more insights from the people we have on the call. And Sascha, if okay, I would like to start with you and ask you, since you are targeting a launch both in Europe and also in the US, what is the difference between these two geographies in terms of timeline when it comes to commercial launch and adoption? And what are your feelings towards these two geographies?
Yeah, I think quite obviously the US and China are a bit ahead of the race when it comes to the current state in the market. What we see is that technically the timelines are not that far apart, but the path to scale is going to be quite different. What we expect is that there will be meaningful robotaxi scale at the end of this decade. While in Europe, the challenge is that the driving task itself is a little bit more complex. We don't see that this, with all the advancements that we have in the drive performance of the AV kits, is the limiting factor, but we have a quite heterogeneous regulation in place. We require homologation, and this puts a lot of stress on the matter of integration that needs to be done by an OEM. So we look on the specific example of Germany. There we have the legal framework that is the Autonomous Driving Act that enables level 4 operation in defined areas and on public roads. And this requires the vehicle to be homologated under UNECE system and specific national law. And this is not just a software topic, as it requires full system approval with quite strict requirements on safety, behavior, and data. And for this, we need to integrate redundant systems such as redundant braking, steering, power supply. We need to have the diagnostics to prove that the systems are robust in terms of SOTIF. So it's a quite complex architecture in itself, and so it took a while for the whole OEM and tier one ecosystem to adapt to this. In the US, the regulatory path itself is a bit more fragmented and often driven at state and city level, and this just allows a lot faster operation, and that's one of the main reasons why we see players such as Waymo operating in the US. Self-certification for the vehicle is a quite less strict requirement. So a lot of the key questions that we have in the European market that are required to get ahead into operation are not relevant in the US market. I think still key for all matters of scale will be the question on the cost of human drivers compared to the cost of operation of the autonomous vehicles. And I think here the race is still quite open. But we expect with all the advancement and now with, I would say, a stronger belief on the capital market perspective into the whole autonomous vehicle industry that we will see this human cost parity to happen in 2030, 2032, and obviously this will unlock quite relevant and fast scaling.
Thank you so much. Going into a different use case, Dave, you're obviously working on autonomous trucks, and you've announced with Torque that you're going to launch first in the US. Why, other than the fact that you're obviously a US-based company, why did you choose the US and not any other geography? And Dave, you're on mute.
Definitely for torque, for autonomous trucking, the US is by far the best market to launch autonomous trucking with a, as was mentioned by Sascha, supportive industry regulatory environment there. But basically, it comes down to a handful of facts. One is from a market size perspective, the US long haul trucking market is roughly 800 billion with a B size. So it gives an extremely large market to go after. There is driver shortage, significant driver shortage, and high driver turnover of almost 90%. There are safety factors in the US, about over 5K human fatalities a year and over 160K injuries per year due to trucking. And so but most importantly is around the driver wages, which are increasing much faster than inflation. So that driver cost is a significant motivator. And this provides, I will call it the fuel for autonomous trucking. The other aspects are from an ODD or operational design domain, very homogeneous within the US, so it's easy to cross state boundaries, et cetera. And then, as I mentioned, regulatory is quite supportive, especially in the southern states, the Sun Belt, which will be the first markets to unlock. And from a torque perspective, as an example, our launch lane is Dallas-Laredo. Laredo has actually become the largest port of entry in the US with about, it's actually amazing if you ever see it, about 14,000 trucks going north and 14,000 going south every day. So just that one lane alone has a massive amount of volume. So just imagine multiplying that across the Sun Belt. And then another thing from a torque perspective is the shadow effect of the OEM partnership that we have with Daimler Truck. They are the leading OEM in the US, significant majority market share, and with the large fleets. And those are the ones that really will adopt more quickly, these fleets with hundreds, thousands, tens of thousands of tractors under their operation. And that provides a very fast path to scale. And so, from a torque perspective, it kind of sets us apart in terms of being able to deliver a scalable, profitable autonomous trucking solution, working closely with our fleet partners.
Amazing. Thank you so much, Dave.
Yep.
Moving on to private vehicles and deep diving into private vehicles for a bit. So as another question, we asked our expert panel, our 91 participants of the survey, how they think about the adoption of private autonomy and how they think about the different levels, if you will. So we did create 3 different scenarios that we asked people to vote on, and we had asked the same question also 2 years ago. What is interesting to see is that there is a bit of shift towards people believing that the mass market is going to be L2 plus rather than level 3 or above level 3. Not a super relevant shift, but it seems to be that people have become a bit more conservative about what levels of autonomy to expect in private cars at scale deployment. The question is why, right? So I do believe it is very much due to the cost implications that people think, but then also due to the fact that some of the projects we have seen in the pipeline have actually deployed a bit slower, a bit more slowly than anticipated before. But why don't I again hand it over to the experts and maybe Talmi to you. How do you see the market for privately owned vehicles evolving, and when do you think there is going to be a mass market adoption for level 3? And maybe there are also some geographic differences that you would like to highlight.
Yeah, thank you. So I think that generally speaking, when we talk about the overall private vehicle market, we've seen that it generally has kind of plateaued, right? We remain within historical trends, but I think that we're just kind of going back to levels that we saw previous to COVID. We are seeing that there are several markets, several developing markets that ownership of private vehicles is accelerating. And what we also see that is consistent across most markets and across regions is that consumers are demanding more safety and convenience driving tech. So OEMs and automakers are pushing to integrate that at scale, starting from ADAS, but moving beyond that to hands-free driving and even higher levels of automation. Regarding your question on level 3, I think that so far there's been some launches that we can consider to be important proof points in the industry, significant milestones. But I think that those are not yet useful or cost efficient enough to reach that level of mass market, mass production, scalable, consumer products. We at Mobileye, we're working with Porsche and Audi on the next generation of these hands-free and eyes-off systems, with other OEMs in our pipeline as well. And we already seeing that it's these systems are spreading widely in China. They're in the rise definitely in the US and getting started in Europe. Europe is I think that is kind of lagging in that sense. I think that what we expect to be a true level 3, what we call eyes-off driving, with a useful operating window that is both safe and relaxing, is definitely the next stage, and I think we will see that starting to ramp up around 2027. I think that the value proposition that eyes-off provides is clear, right? It's extremely clear. It hasn't really changed. The drivers are finally able to get some time back. And that's why I think that there's still excitement around level 3 and eyes-off types of solutions. I think that still many in the industry see this technology as a meaningful step change in the user experience.
Amazing, thank you. And I think our consumer survey, so if we don't ask the experts in the industry, but actual consumers, I would definitely second that. We still see a lot of interest in many of the different use cases, and definitely in use cases that give you a higher level of autonomy and therefore also allow you to do more things in parallel to the actual driving part. Malte, now I know that Talmi mentioned a few other OEMs, but BMW is one of the OEMs that actually already has launched level 3 functionality. So what is the feedback you're getting, and walk us through how you see the adoption happening in future introductions and how you think this is going to change the way how people use their BMW vehicles in a day-to-day basis?
Yeah, sure. So we launched our L3 system, the personal pilot, back in 2023, sorry, 2 years ago, roughly 2 years ago. And the feedback is generally very positive. Yeah, like Talmi said, the feedback we get most is the time the driver gets back for stuff like they want use their cell phone, answer emails, chat to the co-driver. This is the key value proposition of this feature. The other feedback is, and this is where we're kind of proud of, is that they feel very safe using the system. We build in UX like with additional indicators in the steering wheel stating clearly who's in charge, the driver or the vehicle. And this is the feedback we get is well received from the users of the system. Like they know the intention. We have built in voice feedback, so they clearly know what the car is doing next, why the feature is, for example, not working, when it's working, when it's available, stuff like that. So big point here. Regarding the adoption, of course, it's our version 1 system. So these are clearly early adopters, like they are tech savvy, they are into the tech, they like to have this new stuff. And yeah, are happy early customers. Let's put it this way, because for sure this is version 1 of our system, and so it's no secret that there are some limitations still applied to the system. For example, it's highway only, our feature. It has a speed limit, stuff like that. So you need to be an early adopter to buy this feature. But we are taking this feedback that we get from these early customers and to build upon for our future strategy and the next systems that we are planning for the future.
Thank you so much. Happy early customers. That's always great to hear.
Yeah.
Moving on to a different question we did ask to our expert group. It's a question that we actually added in the 2025 survey because it was much less of a hot topic 2 years ago when we did the survey in 2023. We did ask how people think about the separation between China and the rest of the world and whether they believe there is going to be a dedicated stack for China or not so much a dedicated stack for China. So as you can see here, we gave 4 options to be chosen in the survey. And as you can see, you've got a 3/4, 1/4 sort of split between 25, 26% that say there's going to be one global ADAS and AD stack for the entire world. And 75% roughly say that's not going to be the case. We're going to see different stacks for the world. And this then breaks down into different options between separate stacks. So one for each geography, Europe, US, China, a dedicated China solution with a solution for the rest of the world, and then a dedicated US solution as the last option. Now, why do we see this happening? There's obviously a regulatory topic here and a sort of software topic between the US and China. But on the other hand, we also see that the consumer preferences between China and other parts of the world are different. So we do see that the European and the US consumer, especially when it comes to private cars, are much less excited about autonomous driving. And to say it positively, for a Chinese customer, this autonomous driving feature is much more of a buying criteria compared to the other geographies. And then at the same time, we also see that the systems are being used differently and that the use cases are slightly different. So that might also explain why there is another reason to have dedicated solutions for China versus parts of the rest of the world. Now, handing it over to Malte, actually, again. Malte, you chose, as BMW, you chose different solutions between China and other geographies. How do you see the benefits of having a global solution versus those 2 solutions or multiple solutions even across the different continents and countries?
Yeah, the feedback resonates pretty well from here, actually, because we also see the regulatory hurdles between these geo regions as the main challenge right now. For sure, the benefits of one global stack is the efficiency in your development. Yeah, that translate to speed, to costs, when you just only have to build one stack for the global market. On the hardware perspective, we want to maintain this. Yeah, like we have one hardware setup for the world to still maintain these efficiencies. But on the software side, we see the benefits of building a local China stack, because also of different customer requirements, how they want to have their system interact with them, how the local driving behavior is in the local Chinese markets or neighboring countries. So in the end, it's a mixture between development costs, time to market, and local requirements. And this was the decision process that led us to choose those 2 stacks, one for China, one for the global world. And actually, we don't see any changes in the near future. We want to, or hope for the best, that it don't disassemble in the scenario 2, like we have for each geo region, because, as I said, the development costs and the efforts then would go up even further. Yeah.
Amazing. Thank you. Maybe Talmi, to get the tech company and the supplier perspective, what is your view on this? What are the arguments of having a global stack versus dedicated regional stacks?
Yeah. So I think that our position is a bit different from the OEMs, like was stated before. For us, the key components of our stack are region-agnostic. Of course, we always need to make sure that our applications reflect regional needs. For example, intelligent speed assist that can be able to read in different regions. But at the end of the day, the application, the technological application is universal. Well, the details are tailored to individual countries. I think that OEMs are more exposed to local regulators, and that therefore they probably need a more localized strategy. But at the same time, we do develop localized variants, of course, to meet these similar regulations. But our approach is that we try to rely on a global scale, right? Leveraging our ecosystems on chip, trying to maximize the synergies that will allow us to increase the speed of innovation, be consistent across all regions, across all solutions, and be able to leverage our talent. So I think that's a bit different, our approach and the way that we face this issue of regionality.
Awesome. Thank you, Talmi. We've been talking a lot about the regional differences now and the different stacks, especially for private AVs, but let's maybe also bring the robo-taxi, robo-shuttle, shared autonomous mobility perspective into this. And a question to Sascha. Sascha, when you think about the market for shared autonomous mobility in the different regions, do you see there is going to be players that are truly global? Do you think that Chinese players are going to play a role outside of China and also in Europe and the US? And how do you think about the competitive environment?
Yep. From our perspective, we think that shared autonomous mobility will grow in all major regions, but with very different flavors. So as we can already see today, China and the US are very likely to lead in speed, while Europe will be more focused on the integration with public transport, and this sets a different tone in the adoption. So we look on the situation each by each. It's in China. We think all the players are moving very, very fast now with the rise of the end-to-end AI models and the fast development cycles at the OEMs. They have a very strong growth rate ahead of them. The challenge that we see is that their domestic market is not commercially really desirable due to the low cost of the human drivers. So I would say more or less all Chinese players are doomed to go internationally, and that's the strategy that we see. So the deployments in the Gulf Cooperation region, in Switzerland, as a first beachhead in Europe, this really gives a clear path that the players from China wants to capture part of the international market due to the situation in the domestic market. I think it's quite unclear whether the vehicles that they're currently using will be compliant specifically for EU operation. And furthermore, what we see in the market, also in certain requests from the GCC region, but also from Europe, we see that there will be stricter expectations on data localization, cybersecurity, and the supply chain. So we think this will ultimately not stop any Chinese deployments abroad, but it means that they will likely need strong local partners and transparent governance models. If we look into the US, I think it's quite obvious robotaxi is the way to go. So it's a mix of tech-led and TNC-led services that we predict for the upcoming years, and often in selected cities or corridors where regulation and the business case lines up. So Europe, there on the other side, is a bit more cautious, but it's also more politically coordinated. So we see that the way in Europe is likely going the path of shared AVs in public transport as a complement to mass transit. And this is currently the wish of cities, regulators, and operators, and that's why they engage quite actively into the market development. So ultimately, if we look on the long run, I think the matter of adoption is quite simple. It's there where you can earn money, both in robotaxi or in public transit operation. And we see that the shared AVs make the most sense in dense areas, also with a strong public transport backbone. So for first last mile services, suburban feeders, airport links, I think that's the great spots where high utilization provides a clear public benefit. And this is likely to be the place where we see the adoption also being commercially viable.
Fantastic. Thank you so much. We've talked a lot now about adoption, about regional differences. Now, Martin is going to take you through a bit of an overview on cost. Martin, over to you.
Yes. we have asked the same experts how they see what investment is required for really commercial deployment of different use cases. And what you can see here on the slide is if we are talking about level 2 plus level 3 use cases on the highway, it's around 1 billion. If we are talking about level 4 systems, depending on the use case, 4 to 6 billion US dollar until commercial launch. You can also see, especially with if we are moving into urban areas, the software development cost and also the validation cost increase significantly. So we are talking about 2-3 billion US dollar here until commercial deployment. For the trucks, we see that the hardware development costs are higher. I think this is a dependency on the form factor where you need to also build the redundant chassis for the autonomous operations. And on the right-hand side, you see how the cost estimation has changed compared to our 2023 survey. While robotaxi has been pretty stable because there's already in the scale-up phase, the estimation for autonomous trucks have increased by 50-60%. But if you're talking about hub to hub, still lower investment required compared to the more complex urban environment of robotaxis. If we then go on the next page, we also see we have asked the expert, where do they see the biggest challenge or the biggest bottleneck on the way to deployment? And I think number one is with a big margin, the high cost for development and bringing the systems into the market, followed by 3 medium important factors: product liability, low profitability, and unclear regulation. I think there's also some differences across regions. If we are then looking into what is driving the high costs, we see that it's the cost for software development, but followed by high cost of integration, testing, and validation, high cost of data collection, but then also followed by bills of materials, so the sensors and the high performance compute required for autonomous driving. I would here now ask Dave again, if you're looking into trucking, we've seen there is a significant invest required. Where do you see the major pain points in the trucking use case on the way to commercial deployment, and how is Torc addressing these challenges?
All right, thank you, Martin. Yes, I think the charts do reflect some of the pain points that we see in general. But I think if I touch on this, there's probably 3 areas I'd like to focus on. One is around the OEM partnerships, which touch on the hardware costs as well as the unit economics, as well as the ability to deploy and scale quickly. The other piece would be around the move to embedded and scalable productization. And then the third is around safety, actually, as a pain point that needs to be addressed and to build the confidence. And so if we touch on the first with OEM partnerships, the path to adoption by the large fleets really comes down to reducing their risk profile and the TCO that we are able to provide. A big piece of that is that, I mean, from our Torc Autonomous Advisory Council, a group of like the who's who of the fleets, we get clear feedback that they'll only adopt a factory integration. So basically a fully redundant autonomous ready chassis on the hardware side and obviously production software. And so really this is something from a Torc perspective. With Daimler, we have an advantage there as the largest OEM in the US for trucking. And currently they already have a production intent hardware coming off of their main line for the fully redundant chassis, which is also including production intent software. So, we're past the R&D, past the advanced engineering and the productization right now. That actually sets us apart from all of our others. But this is critical for the fleets to not only have the confidence, but be able to quickly scale for them. And that will enable, and our partnership with Daimler enables us to get to good unit economics on hardware costs, as well as I mentioned, to scale. The other thing to set that another piece there is around operational support, which wasn't quite captured. Once you get that truck, you need to operate it. How do you handle the maintenance support that's needed? You need to have that ready-made support environment. One thing that Daimler has in large scale within North America. So that OEM partnership is really critical to address a number of these pieces that are mentioned as cost drivers. The second one I said was around move to embedded and scalable production. Uh, Anyone in the space knows that that move from into that productization phase is extremely painful. It's a massive effort to go from your R&D and advanced engineering code that's running on servers, et cetera, into the production embedded platform. And so one thing we did was actually made a strategic decision to do that up front in lockstep with Daimler. So that's why our software is also on that front. And get through the integration hell, as they call it, earlier rather than later. And so this allows really quick scaling once we get to series production. And then I did want to touch on that safety topic. And so this is one of the areas that it's about the confidence. When will the customers feel confident to adopt the technology when the driver gets pulled out on the particular launch ODDs and then scale from there? And that is something that we're doing with our working very closely with Daimler on that and our fleet customers on our path with our what we coined the AV 3.0 approach of end-to-end reinforcement learning with heuristic guardrails for our virtual driver stack. And so this is a critical piece that allows us to adapt very quickly and get to that many nines of confidence to pull that driver out and allow the fleets to have their confidence to start being able to scale. So those I think are the kind of the main key components that we see our customers reflecting back to us. And definitely acknowledge, I think some of the more traditional things in the list apply, but I wanted to highlight those as the concerns that are at the top of mind for our customers.
Thanks, Dave. If we go to the private car space, Malte, how's this the same or different to BMW? You're developing ADAS AD. Where do you see here the major cost drivers and what can be done to reduce the costs?
Yeah, from a private ownership perspective, I would say it's test and validation on the one hand, and on the other hand, the costs for the hardware stack itself. Yeah, like bill of materials. Let's stay with the validation and testing costs. We want to increase our footprint globally with our system, so we have to make sure that it's working correct and compliant to regulatory, in not just Germany like it's doing right now, our current system, but in the EU, in China, of course, in the US as well. So the whole process of data collecting, data annotation, processing, and for the development, and the bigger part is for the validation efforts and also the simulation efforts are quite intense. Yeah? And for the future, we are decreasing these costs using more virtual tools, more AI-based tools, for example, annotation, stuff like that. But it still will remain one big part of the cost sheet, yeah, the test and validation. And for sure, it's the good thing because we want to have a safe system in the field for our customers, and yeah, still keeping up the safety standards here. On the other hand, bill of materials, as I said, we want to scale it down, not just for the 7 Series. We want to scale it down to the middle price range of our portfolio, and then you always have to discuss what's the optimal price for this customer segment, what they are willing to spend for such a system, because when we want to have also not the regional footprint, but also the footprint of our vehicle portfolio. So the hardware costs for the sensors and obviously for the SoCs is one critical topic for us. And the cost of the SoCs regarding performance requirements are still increasing. We are not seeing any plateau here from the requirement side. So the costs are still going up here based on coming AI platform systems.
Yeah, if I may build off Oh, sorry. I was going to say if I can build
No,
off a
Dave,
little on what
go ahead.
Malte said. I think he brought up a very critical point that I wanted to emphasize from our perspective as well. For trucking, I would say most of the miles driven by trucks are very boring miles. It's on highway that you don't see many corner case scenarios in typical days. So the proxy of saying how many driven miles your order or orders of magnitude more than probably passenger in urban environment. And so that's one thing that we've invested very heavily on from an AI perspective is a very robust way of doing world simulation, applying really cutting edge novel or cutting edge neural rendering and um, generative AI techniques for scenario generation to really expand, as I mentioned, out to those nines of covering a very um, corner case level of activity that could happen on the highways. And yes, we do drive on local streets between the distribution centers and things of that nature, but the majority is highway. And so this very advanced data loop and world simulation is critical to achieve that safety goal that I mentioned earlier, and get to we'll call it the hundreds of millions of miles of driving safety so that we can be confident to take that driver out. So yeah, Malte, I just want to build off on that on some of the really cool stuff Torque is working on.
And maybe then also quickly, Sascha on robotaxis, are these the same challenges or do you see different challenges if we are talking about shared
Mm.
mobility in urban cities with
Yeah.
robotaxis and robo shuttles?
So first of all, I think with the AV technology, we've come quite a long way during the last 10 years of development, but technically the long tail of rare events is still very, very hard. So we see that many pilots stay in demonstration mode. They never become real products at scale. So that's something that we still see that there's a lot of work to be done. At the same time, all the progress made on end-to-end AI system is for us very, very promising, especially when it comes to the scalability due to less map dependency and being able to cope with the rare events. But still for us, it's a very new technology. So the whole validation verification piece is still an issue where we see that we will need some time in the industry to figure out how this can actually be integrated into a vehicle that is then operated. The second point, I think I've touched it before, is the economics and the intensity of capital that is needed. So for all that is happening, still external money is pushing the boundaries. So whether we look on the operations, when we look at the vehicle platforms, so this is all pushed and not earned. And we often hear in the industry that like if someone would have a cheaper vehicle, then miraculously all the problems will be solved. And I think that's a bit too easy. I understand this from a tech perspective that you say, okay, if someone is able to build me a vehicle with all redundancy for 20K US dollars, then I will have a large profit. But it's just not the reality. We think that the whole system optimization is really necessary to get down to low TCO. So all levers need to be pulled, whether it's the cost of compute, cost of sensors, the ratio of remote operators, uptime optimization, but even things like robust after sales. So if you have snowflakes of vehicles, then they are costly to operate and nothing that you can hand over to a fleet operator and they take it into a day-to-day operations at low cost. So we see that there's still way to go in the industry to really create a hard product that is then sellable at a large scale. I think regulation is an often talked topic that I don't want to dive too deeply in, but then there's one specific aspect that we think is still a bit unclear when it comes to scale, and that is the role when it comes to liability. Specifically in the European market, but also in the US, I think the role between the OEMs and the AV kit providers is still quite unclear. So I think there's a clear demarcation to the TNC or demand generation business. But when it comes to the interplay of validation verification on how to create the safety metrics, on how to ensure that the vehicle and the SDS system as a whole system is safe and reliable, that's still an area where I think there's still precedence needed to really find out which kind of configurations in the market will work. What we see is definitely a way forward in where we will see less integrated players. So if we look on the economics, if we look on the challenges in the liability field and also technically, we think that the role of the OEMs, but at the same time also the TNCs will be a bit more visible in the near futures. And such as our company, we focus on the vehicle integration, validation, verification, the whole system management, and also functions like passenger management, fleet control. And we think that with the rise of new players in the SDS sector, also new vehicle form factors specifically built for AV operation, there will be a need for such players who just push on time to market. If we don't have this vertically integrated approach that we see predominantly in the R&D projects and in the first commercial projects right now.
Yeah, thanks. And you already built the lead to the last page because you mentioned end-to-end autonomous driving. We see the disruption in AI, large language models also being applied in the ADAS and autonomous driving field. And we asked the expert, which approach they see will be dominating in the future. And we offered like a rule-based approach, a mixed approach, combining an end-to-end model with some, let's say, rule-based algorithms, and then a pure end-to-end approach. And the majority said it will be a mixed approach, and around 20% believe it can be an end-to-end approach alone. If we are looking into the different use cases and level of autonomy, if we are only looking at level 3 and above, then the share of the mixed approach would be even higher. On the right-hand side, we see that as the expert estimate, there is a moderate or significant cost savings if we are moving to an end-to-end approach. But, and I think that was also mentioned by Sascha, the regulatory and safety concerns are still the biggest concern of the end-to-end approach. And I think here I would maybe ask quickly Dave and Talmi to basically help or explain the different approaches, benefits and drawbacks. And maybe to Dave, Torque just announced the modular end-to-end approach. Maybe you can quickly explain what it is and what benefits do you see from this approach?
Yeah, absolutely. So just a second on the kind of evolution, right? We all started with classical approaches and starting with perception and then also control. We then moved to replacing certain functions with AI-based approaches. And in the mixed approach diagram, it started with perception with more traditional prediction and planning. And then there was the AV 2.0 approach of pure end-to-end for the whole stack. Challenge with pure end-to-end, while it did give much better results, is just the transparency and visibility of what was going on within that stack and how you validate that for your safety SPIs. And so while the evolution and ability to adapt is faster, it's essentially a black box. And so we early this year announced our AV 3.0 approach, which really is combining the best of both worlds, which is taking an end-to-end learning approach with the rules-based or heuristic guardrails. And this activity is led by our head of AI and also Princeton professor Felix Heide, one of the top AI leaders in this space, and also backed by just an amazing team that basically provides adaptability, a quick path to expand ODD, etc., but the highest performance for the full range of, I'll call it, features or functions within the tech stack of the perception, prediction, and planning, while properly constraining that AI for the driving rules that we're going after. And so this is combined with really achieving to best achieve those safety goals. At the end of the day, we believe that I would call it the hybrid approach that comes after AV 2.0 in your diagram. And not only will that provide the transparency to allow us to expose our safety results, as I mentioned, through the very extensive world simulation that we're doing, but also tie in training into that loop. But allows us to quickly adapt and scale to the different ODDs, which then addresses the fleet's needs to quickly move and scale the unit economic and TCO advantages into their fleet requirements. And so I think that sort of approach is absolutely critical for autonomous trucking and frankly, any autonomy platform. I don't believe you can get there purely with AV 2.0 in its current form. So that's why we basically implemented that. And one of the great things, that terminology is starting to be adopted more and more. NVIDIA is starting to use end-to-end plus guardrails and things of that nature, and others have adopted that too. So I think that's a great move in the industry to ensure that we have high performance plus safety. So I'll leave it at that. And
Yeah, then last question, maybe Talmi, also Mobileye is implementing AI in the ADAS stack since a long time. Maybe you can also highlight a little bit what are the benefits and challenges of this AV 2.0 and the mixed approach.
Yeah. So I think Dave has addressed this very, very well. I think that right now, when we look at almost every company that has a no driver robotaxi or no driver commercial truck on the road, that has talked about their AI system that use this, we call it hybrid, we call it compound AI, right? Where we see a mix of end-to-end networks with more structured solutions. We're seeing that there are companies that are trying to apply these so-called end-to-end monolithic end-to-end solutions, and they're already running into issues explaining this to regulators, because as Dave was saying, these are essentially black boxes, right? We don't know how they've been trained, we don't know on what scenarios, with how much data, and scaling that to automotive grade and being safe remains a huge hurdle for these companies, and we see a lot of risks for the validation process. I think that, again, like Dave was saying, I think that industry is in your service is showing is that the industry is really converging into this compound architectures where explainable AI is becoming very critical. So again, our approach is very similar to that. I mean, we try to enable trying to leverage this traditional pipeline that you mentioned here of perception, prediction, and planning in a safer manner, and at the same time adopting end-to-end networks via VLAs, VLSAs, as we call it, to combine the benefit and the speed of flexibility with a framework that provides that safety and transparency that we're talking about earlier. I think that we believe that the compound approach is safer. And I think that we at Mobileye, we're also in a unique position, being able to put all these into global automotive scale, because we've been developing these this first layer, this first safety layer for years. We have hundreds of millions of vehicles on the road, so with a proven solution. So I think that's the approach that we're taking around this.
Thanks for sharing. And I think that was my last question. I think took a little bit longer as expected, but I think we still have time for one or two questions. Maybe, James, you have been monitoring the Q&A. Maybe there is one or two which we still want to discuss here.
Yeah, thank you, Martin. And thank you to everyone that asked questions. Clearly, we're not going to be able to get to all your questions, but we do appreciate you sending them in. Let's start with this one, and we'll try to do a rapid fire maybe for each of you. A question is effectively around, is the industry prioritizing speed over safety. And to summarize here, the argument is it seems like pace is accelerating. I think we're all feeling that, whether it's in our LinkedIn or X feeds. We're seeing more activity. We're seeing more press releases. But I also want to provide a counter that maybe you could answer too. If it's not, the industry's not providing speed over safety, I want to leave you with a quote from the New York Times yesterday. Jonathan Slotnick, a renowned neurosurgeon here in the United States, had a New York Times opinion piece yesterday where he was talking about really looking at the Waymo data in the United States. And his conclusion is, in medicine, when a treatment shows this level of benefit, we stop the trial early. Continuing to give patients the placebo becomes unethical. When intervention works this clearly, you change what you do. So I wanted to ask each panelist, do you think we're prioritizing speed over safety, or are we actually prioritizing regulatory capture over safety? And I'd just be curious, each one of you, where you think we are as an industry. Dave, I'll start with you.
I'll give it from a trucking perspective, and since I'm based in California, I've taken plenty of Waymos. I definitely applaud the approach Waymo has been taking, which seems to be a measured approach in terms of scaling and has shown a very good safety record to date. Obviously, more transparency is always appreciated. On the trucking side, speaking from a torque perspective, we have safety across our DNA. It's very deep for us, and that's, again, why we decided to do a novel architecture to ensure the transparency, et cetera. And with our partner with Daimler Truck, we are not going to take a driver out until we feel safe. There have been moves to take some drivers out in our space, then drivers got put back in, then taken back out. So I think there is a rush to sort of deploy the benefit of autonomous trucking to our customers. But at the end of the day, we're going to launch something that's production ready, that's well qualified from a safety perspective, and has the trust for our fleets to then not only do 10, 20, 100 trucks, but really move to 10,000, 50,000, et cetera. So that's really where we're focused. Safety and scalability tie together for us.
Talmi, good to you. Do you think the industry has been able to go at the speed it needs to, or do you think it's the incumbent regulatory capture has slowed people down unnecessarily?
No, I think, first of all, I think that from Mobileye's perspective, again, we're a safety first company. We exist because we want to provide safer vehicles. We want, for us, safety is always going to be first. And that's why we're taking that approach. Also, when we were talking just a couple of minutes ago about these end-to-end networks, where these are integrated into vehicles, we believe that safety will always come before speed. And I think that regulators generally, again, it's different across regions, right? China is not the same as the US and Europe. We spoke about that before, also in terms of speed of adoption. So I think that generally speaking, in some parts of the world, probably regulators are prioritizing speed. In other places, regulators are more concerned with safety. But
on that, Talmi, could you give me a market where you think regulators are prioritizing speed?
Well, I think that probably in China, regulators have been a bit more flexible. I think that maybe that has changed lately, but at the beginning, at least, there was more flexibility in China towards speed rather than safety. But I think that generally speaking, and as an industry, I think that safety is still coming first instead of speed.
Yeah, Sascha and Malte, just to round it out here, there's a lot of questions around Europe, and it looks like from the data, even the widening gap between Europe and what is often considered their peers in the US and China markets. How does that gap shrink? Will that gap shrink in the coming years? Curious on both your thoughts.
Yeah, Malte, you want to go first?
Yeah, let me take the safety aspect. Also, BMW's position is that we will release a feature when it's safe for our customers. So I guess it's through the industry that nobody wants to sacrifice safety here. So Is the gap or the regulatory speed in the geo regions differently? I would say yes. As Talmi said, we also see China as a fast-moving country regulatory-wise. They're moving a kind of back with their L2 GB right now, but they are at the forefront. Yeah. The gap from Europe, I don't see if it's really a gap regarding regulatory or the industry. Maybe the preferences of the customers are also a little bit different region-wise. The China customers are really tech savvy. They are hungry for new tech. They're also in the demographics slightly younger than, for example, in Europe. This also leads to a shift in preferences. But we don't necessarily see this as a fixed state. It's more like China is the front runner, and the rest of the geo regions will follow. Because, as I said in the beginning, the value proposition of the system is always the same, and we don't see a difference in the need or in the appeal of using the driving time for other stuff.
Sascha, maybe to finish us out?
Yeah, so I think the market entrance boundaries in Europe due to the homologation requirement and overall due to the rather scattered regulatory environment is more complicated. So that's the reason why we don't see any meaningful amounts of vehicles operating and no driverless vehicle at all. So this will likely be overcome in the next 2 to 3 years. That's our timeline for homologation of our serial production vehicle. So then definitely the game will change. But still, Europe is a different market. So it's separated into all the national regulation and the national preferences. And therefore, I don't expect the speed of scale to be on par with the Chinese, the GCC, or the US market. But it will be a market that definitely will grow due to the aspect of demographic change. So I think with the driver scarcity that will hit public transit in Europe in the years 2030 onwards, this will definitely speed up the adoption. And at that point in time, also the cost of robotaxi operations will be on par with human driver. And this will definitely unlock operation, at least in the industrialized or strongly industrialized countries in Central Europe and the Nordics.
Great. Thank you, Sascha. And thank you to all of you for participating with us today. I did want to leave you with one final comment, which is we have the Ride AI Summit next year on April 15th. I hope all of you will be there. There's a wait list currently to join. You can go to rideai.org and see that. I want to thank McKinsey again, Kersten and Martin, for co-moderating and co-hosting this discussion today, and hope to do more of this in the future. So thank you so much and have a wonderful day.
Thanks, everyone. Have a good one.
Thank you.
Thanks, James.
Thank you.